Hello everyone, thank you for attending today's webinar. There are several factors driving automation in the lab. Specimen handling regulations and best practices require implementation of a robust quality management system, including for specimen identification and tracking. For example, the primary goal for JACO and CAP this year is to ensure correct patient and specimen identification. And the CLIA Auto 12A specimen labeling method using standard barcodes has an implementation deadline for clinical labs in April 2014. A rising need for collaboration is also driving a need for robust specimen labeling and tracking. Clinical labs provide specimens for use beyond patient diagnosis and are sharing with medical, biotech, and academic research. We're also seeing industrial labs collaborating with academic research. In a recent survey conducted by Brady, 75% of the respondents reported sharing samples with other labs. Therefore, it is important that the identification of the specimens survive handling and processing not only at the initial lab, but at additional labs in the collaboration stream, as well as transportation in between. Workflow improvement is a large topic in the minds of many lab managers and directors today, as cost pressures and a shortage of qualified laboratory personnel continue to put pressures on the success of their labs. In their 2013 Life Sciences Market Overview report, Bioinformatics states that labs face enormous pressure to accomplish more research with fewer resources. Labs are implementing automated tracking systems and lean improvement methods as a way to optimize workflow and reduce cost, the success of which is necessitated by durable barcoded or 2D coded specimen labels. Probably the most important driver of automation in the lab is the need to reduce errors related to specimen identification, handling, and results reporting. Errors specific to labeling include mislabeling, unlabeled specimens, usually because the labels fall off during processing or storage, and incomplete or illegible labels. These types of errors not only risk patient safety, but also add cost to the lab when technician hours are needed to find, rematch, or recollect lost or misidentified specimens. In a UCLA Med Center study of 120 institutions and more than 16,000 potential errors, over 50% of the errors were due to mislabeled specimens. Laboratory personnel deal with chemicals, stains, and extreme temperatures, such as liquid nitrogen or autoclave applications on a daily basis. So they may not view these as harsh environments, but to a label, these types of environments can have a detrimental impact to the performance of any and all parts of the label construction. Labels used in specimen identification, or any application for that matter, are constructed of three main parts. The top coat is what the ink, whether it be chemical, resin or waxed ribbon, toner, or pigment, adheres to when the label is printed. The adhesive is a compound of different chemicals which adheres the label to the surface, whether that is a cryovial, blood tube, slide, or tissue cassette. The label face sheet is a material which acts as a carrier for the top coat on the top and the adhesive on the bottom of the label. For normal, everyday applications, such as file labels or shipping labels, a paper face sheet is completely adequate. But anytime there is an environment which includes extreme temperatures, chemicals, abrasion, or other types of processing, it is important to use a synthetic face sheet which will resist tearing or disintegrating in a harsh environment. There are many different label suppliers to choose from. Because the lab includes various harsh environments, it is important to find a label supplier who not only carries labels designed specifically for your laboratory process or application, but who can also show test data in that environment. Therefore, as you work to implement an automated labeling and tracking protocol in your lab, it is extremely important to select a label material that will withstand the environment in which the specimen will live throughout the entire life cycle of the specimen. For example, your lab may be creating slides for a particular pathology case that day, but the tissue block will most likely live on far longer somewhere in long-term storage, possibly in a biorepository or a biobank. Failing to choose the right label may result in a hiccup in your automated labeling and tracking protocol, losing precious time and money as lab personnel have to relabel the specimen, find lost specimens, or rerun a batch of tests because one aliquot failed to get read by the machine. One study from a clinical setting estimated the average cost of one lost sample to be over $700, not including the cost of patient anxiety, misdiagnosis, or the resulting lawsuits from misdiagnosis or fatalities. But on the positive side, choosing the right label material will allow you to label your specimens pre-process, saving you time and money by labeling the specimens only once versus matching handwritten specimens with label sets after processing has completed. It can also improve patient safety by helping to eliminate mismatch errors, which can result in misdiagnosis or a delay in reporting test results, or even death in the most extreme cases. Just as the label material itself is extremely important to implementing a successful automated labeling and tracking protocol in your lab, the print methodology chosen will also have a large impact as well. If the print itself does not survive specimen processing and storage protocol, it is the same as if you never labeled or identified the specimen in the first place. Various print methods are used in the lab today. Handwritten labels with a pencil or permanent marker, laser jet, inkjet, direct thermal, thermal transfer, or laser etching through a direct mark system. It is very important that you understand the advantages and disadvantages of each print technology as you are implementing your labeling and tracking protocol. For example, direct thermal printing is quick, but does not do as well in extreme temperatures as other methods, such as thermal transfer. Laser etching can also be a quick automated way to apply identification directly to your specimen container, such as a tissue cassette or vial. But you should ensure that the equipment can create a barcode or 2D code with enough detail and crispness to be scanned quickly and easily at various points in your tracking system. Brady's core competency lies with thermal transfer print technology because it creates a crisp and durable image that will withstand many different harsh environments. Although it may be a bit slower than direct thermal or more costly than an ink or laser jet desktop printer, it is a very versatile print technology that works well across the entire lab. It also allows, as with direct thermal, for different sizes of labels and printers themselves, from portable handheld printers to 6-inch wide or even wider print systems. In conclusion, with the proper label selection, you can have the confidence to label specimens pre-process without losing specimen identification and other important tracking information. The right label will help you eliminate mismatching errors and lost specimens due to label failures and maximize the potential of your automated tracking system. Recommendations include: number 1, eliminate handwriting on specimens in all areas of your lab. It adds too much risk to your system. There are many options available to make it easy to print on a durable label, whether you are labeling 1,000 specimens per day or just a few at a time. Number 2, know your environment and select a label material that has been designed specifically for that environment. Number 3, look for evidence. Find a label supplier who has developed labels specifically for the lab environment and ask for technical information showing test results for the label and print in your specific environment. And test, test, test. No supplier can recreate your exact specific lab environment, so ask for samples and test in your lab to confirm. And number 4, pre-process labeling is the key to reducing errors and improving workflow. Eliminate mismatching errors by labeling at the point of collection, aliquoting, or grossing, and not after the samples have been processed. We're here to help. If you'd like more information about labeling in a lab environment, please visit us at www.bradyid.com/lab to review our laboratory product offering, including labels, printers, software, and scanners. You can also download product information sheets, technical data sheets, which include test results, and our laboratory identification catalog. You can also download a white paper written around best practices for specimen labeling.